sources of carbon in nature are numerous and diverse. In its pure form, carbon occurs as diamonds, graphite, and anthracite, but more often it is part of various chemical compounds. However, only carbon dioxide, whether in a gaseous state, in the atmosphere, or dissolved in water, represents a source of carbon that living organisms can process into organic matter. Under modern conditions, carbon dioxide enters the atmosphere from the Earth's interior through volcanic eruptions, respiration of organisms, fires, oxidation of natural underground gases, and the burning of fuel by humans. The CO2 content in our planet's atmosphere is 0.03%. Approximately one-third of its total stock in the air and in living organisms is in circulation annually, with contributions from ocean and land organisms being roughly equal. Carbon participates in photosynthesis in plants and is returned to the atmosphere by soil microorganisms in the form of carbon dioxide. The most important stage of the carbon cycle is photosynthesis, during which carbon dioxide absorbed by green plants is converted into sugars and in subsequent biosynthesis reactions transformed into complex carbohydrates, proteins, lipids, etc. These substances provide nutrition for animals, microorganisms, and fungi. Only green plants accumulate energy in chemical bonds. Energy accumulated in this way is used within the organism itself and in the ecosystem as a whole. When organisms die and decompose, one part of the carbon is released as gases, while another transitions into non-volatile forms. Saprophagus animals, fungi, and microorganisms inhabiting the soil transform dead plants and animal remains into a new formation, soil humus. The rate of impact of decomposer organisms on humus accumulation varies significantly. Sometimes dead organisms decompose and organic residues accumulate at speed in swamps. Deposits of organic compounds like peat, coal, and oil indicate a slowdown in the grand cycle of matter over geological timescales. Carbon, fixed by plants and subsequently used by animals, returns oxidized back to CO2 into the external environment, where it can become part of any geochemical cycle. In oceans and seas, carbon dioxide is also consumed during the accumulation of carbonate rocks, when carbonic acid of inorganic or biogenic origin accumulates in the form of CaCO3. Often, these masses of carbon remains out of the cycle for millions of years until carbonate rocks rise above the sea surface as islands or mountain ranges. From this moment, under the influence of atmospheric precipitation, crustose lichens and plant roots, the inclusion of carbon and calcium into the cycle begins. The balance of carbon dioxide between the atmosphere, land, and ocean is changing due to human activity. Annually, 6 multiplied by 10 in the power of 9 tons of carbon from fossil fuels are burned worldwide for heating homes, industrial operations, transportation, etc. Over the past 100 years, the carbon dioxide content in the atmosphere has increased from 290 to 320 million tons, with over one-fifth of this increase occurring in recent decades. According to estimates, the total increase in atmospheric CO2 content is only about one-third of the gas released from combustion. The remaining share of CO2 goes towards the increase in plant biomass and part dissolves in ocean waters. The turnover rate of CO2 in the atmosphere is about 4 years. Human activity is constantly intensifying, and the consumption of fossil fuels grows year by year. The content of CO2 and other greenhouse gases in the atmosphere is increasing. Greenhouse gases absorb part of the thermal radiation emitted from the Earth's surface, causing the greenhouse effect, a rise in temperature in the lower atmosphere. This inevitably leads to glacier melting, rising ocean levels, and other equally serious environmental consequences. Therefore, the global community faces the task of finding energy sources and technological processes that will prevent the atmospheric carbon dioxide content from rising so rapidly. It is also known that deforestation and the use of land for the roads and buildings reduce the Earth's green cover area and slow down the rate of carbon fixation through photosynthesis. Currently, scientists are trying to understand the extent of human contribution to global climate warming processes on the planet and what other factors cause this phenomenon.